Hello everyone. This is an overview of week 4. In week 4 we're going to talk about several things. One of them involves static equilibrium, and notice that I have this block and it's sitting on a piece of wood. If the wood were frictionless, if I raise this up it would immediately just slide off, but the wood does have some friction, so we're going to talk about friction forces. And at what angle can you get this block at before it starts to slide off? Well, that depends on the roughness of the surfaces. All right, and so we're going to look at static coefficient of friction and how to calculate that and how that affects whether a block slides or not. If I orient the block like this and tilt this, before it slides, it's actually going to tip over. All right, and so we're going to investigate why that happens as well. Along the way, we're going to need to look at something called moments. All right, so let me use this block of wood as an example. So let me see if I'm in the frame here. Yeah, my hand's in the frame. All right, so I have this block of wood. If I exert a force pushing down right here, that's going to cause me to have to put a counter rotation force with this hand. So I'm pushing down here and I have to rotate here. All right, if I press closer to my hand, I don't have to exert as much force. All right, this is generating a moment. Right, so I push down, perpendicular is the moment arm, and the amount of torque is proportional to that force times this distance of the moment arm. Okay, so we're going to talk about that. It has some interesting practical applications. If I take a look at something like a screwdriver, okay, so the screwdriver, I have a rotational force here, and the moment arm is actually the radius of the handle. All right, so if I have a bigger handle, for the same amount of torque that I put with my arm, it's going to generate more torque at the tip of the screwdriver. Okay, so if you were comparing these two screwdrivers, which one is going to be the one that you would use to generate more torque? Well, the radius of this handle is narrower compared to this one, all right? And so this screwdriver would generate more torque. Okay, so another thing I wanted to show you along these lines has to do with doors. All right, here's another example of a moment arm. Why they put the handle here, okay? It's on the opposite side of the hinge. The hinge is the moment of rotation, okay? And so we put this, a moment arm goes from this all the way to the doorknob, okay? And so I can open the door easier if I pull on, the right side of this door that's hinged on the left, okay? You wouldn't want to try to put a doorknob right here because it would take too much force to open the door. Okay, so about moment arms. We're just going to talk more about exactly how the math on this works. And, I have a project for you to do on week 4 as well. It's going to involve tipping or slipping. Okay, this idea of having, the block here, is it going to slide or is it going to tip? All right. And you're going to work together and put together a PowerPoint. This is something that engineers do all the time. You have to make presentations to justify your work. All right, so those are the things to look forward to in week 4.